Alright, welcome back to another video series by Firestarter Graphics and Engineering. Today we're going to start a whole new project. This is going to be Sketchup for engineers. Now, the version of Sketchup I am using is 2018 Pro, and this video series is geared towards the Professional Edition. Why am I gearing it towards Professional Edition? Because if you're an engineer, which this is for, in the field you need to have licensed software, and the free version of SketchUp, the web version or the Make version that you can download, cannot be used for business. It can only be used for personal projects. Now you can take some of the stuff from this series and actually use it in the Make, and I will do my best to let you know when that is. But let's go over kind of an overview of what this course is. So, this course is for engineers, mostly mechanical or design or structural engineers. Mostly mechanical. We're going to go over design principles, we're going to go over 3D printing, exporting, photorealistic renderings, and a whole lot of fun stuff like that. Thread design, and let's see what else we're going to go over. Presentation. We're going to go over model space versus paper space, how to present your design to someone, how to make working drawings, and we're going to briefly cover dimensions. I am not the best at dimensioning. There's a lot of rules. I will try to incorporate that into this, and we'll go with that. Now, when it comes to structures, I'm not going to do any architecture. I might do a little bit of architecture, just maybe, to show the workflow for that, but that will be later on during the course. So why am I choosing SketchUp? Well, for one, SketchUp is a lot cheaper than some of the top tier modelers out there. I'm certified in a couple of them that the Air Force uses and NASA uses, and they're not cheap, but there's a good reason why they're not cheap. So this course, I mean, you could use SketchUp to maybe design an airplane. I don't know. I wouldn't say I wouldn't risk it. I mean, it's not going to be dangerous. I could do it. It just might take a little bit longer versus another software that would be a little bit more efficient at it. So what could SketchUp do for engineers? Well, there's actually a lot of things it can do. It can do smaller parts such as cars, engines, piping, layout stuff, structures, trusses. I just don't know if I would design a rocket or a commercial airplane with SketchUp. I don't know yet. So, anyways, but for the most part, SketchUp will do 90% of what we want it to do. There's a few things in there a lot of people don't know that it can do, and that's why I'm doing this course. So, with that said, let's kind of overview what's going to be in Chapter 1. That is the first video series. It's going to be multiple videos, hopefully 10 to 15 minutes each. And what we're going to learn is the difference between surface modeling, solid modeling, which is some of them are parametric, versus is my part a solid? So what does that mean? A surface modeler, think of paper like origami. You're folding a piece of paper into something. So take a piece of paper, fold it into a cube. It's hollow on the inside. Now let's say that paper was waterproof. If you were to put water in it, it's solid in the fact that it's airtight or watertight. Water would not leak out. So two different kinds of mindsets for solid. Sometimes a solid, like solid modeling, such as some of the top tier products, means that the entire part, it's like clay or metal, and you're just drilling holes through it or shaping it. More like clay. It's solid all the way through. And if you want it hollow, you have to tell the program to make it hollow. and the parts are always solid. When you're done, you won't have any holes in your meshes. It's always just solid no matter what. So exporting for 3D printing is pretty simple and straightforward with some of these top tiers, and you won't have any holes in what they call the mesh. Now with surface modeling, you can end up having a hole in the mesh that you can't see, and water could leak out, and then 3D printers don't really like that, but nowadays with the slicing software, it's pretty advanced and can work its way through that. So parametric modeling is if you were to update one single dimension in a part, everything else is constrained to that one dimension. It knows all the other information. So you update one dimension, everything is going to adjust according to that. But it doesn't always have to. You can actually make a dimension independent. So when you say you have a gear and you want to make the center hole, instead of a 1/2 inch diameter, you want to make it 0.55. It'll update that and make that hole bigger without changing the dimensions of the other part. So you're basically adjusting certain parameters. That's why it's parametric. It's really advanced. Sketchup is not a parametric modeler. If you want to update something, make sure you have the dimensions right the first time, because odds are, if they're not correct, you're going to have to probably remodel it. There's some workarounds with that, and we'll kind of discuss those. Then we're going to go into the basics of navigation, how the interface to the panels work, the inference engine, rotating the axes versus using guidelines or construction lines. Then we're going to do basic part modeling of a solid, cleanup and export for 3D printing, and then basic rendering for presentations, so photorealistic rendering. There's two different programs I use. The first one is called Twilight, and it's an extension that's built into SketchUp that you have to download. The other one is Illumination, but that one's really advanced and you have to pay for it. But if you're a student, you can get it for free. But the download is like 15 gigabytes, which isn't that bad. I did it over my cell phone. That's why I'm thinking it's bad, because it ate up all my data. But anyways, point is, it's a really good program. So anyway, that's kind of an overview of what's going to happen in this chapter. So without any other questions or concerns, let's go ahead and start the next video and start modeling. So thank you for watching.